Welcome to Narayan Microwave Technologies.
The working of semiconductor switch trend means how the semiconductor will work as a switch. For switching application, we have used LED as well as relay. Here, this MOSFET can work as a switch in this block. Here, the FET will work as a switch. And this block, we have IGBT as a switch. To give the supply to these semiconductors, we have plus 5 volt, a plus 12 volt, plus 5 volt. And for the signal, we have square and sine out. The amplitude and frequency can be adjusted of sine wave, while the frequency can be adjusted of square wave, but amplitude is fixed of the square wave. Now to check the operation, let's turn on the switch by using the on-off switch, which is given at the rear end of our trainer board like this. Now let's perform the experiment. First, MOSFET as a switch. Before turning on, first let's make the connection. Let's connect plus 5 volt to T1 terminal. This ground will be connected to T4. This square out will be connected to T2, and the ground of your sine generator connected to T5. These are the inputs. Now to check the switching, connect T3 to either LED or relay. You can use any of two. First, let's give it to LED. Okay. Let's keep this potentiometer position of amplitude and frequency at minimum position. Now let's turn on the trainer. Here you can see the status of LED, which is at present off condition, and after some time it will turn on. The time interval will depend upon the frequency which we are giving at the circuitry. If we increase the frequency, you can check the timing of LED on and off will increase. See, this the on off, that is switching of our transistor, is increased. Now if I decrease the frequency, the time duration is decreases. Same thing can be observed on our relay as well. So parallelly, you can connect the output of this MOSFET to the relay. As you can see, there is a switching of relay. Okay. If you increase the frequency, you can check the switching of relay will increase as well. These are the terminals for relay, NO, common, and NC. You can verify it by using the multimeter in the continuity mode. So this is for MOSFET as a switch. Let's keep it minimum. Let's turn off and let's make the connection for the FET. For FET, you have to give the plus 5 volts to T1, connect ground to T1 to T10, and here we'll have to use the sine wave to T8, and ground will be connected to T11. For output switching, again, let's use the LED. You can use relay as well. Let's first use the LED. Now let's turn on it. See, as the frequency is very low, so the occurrence of LED on and off will also be very slow. If I increase the frequency, so you have to increase this potentiometer. See, as I increase the frequency of our sine wave, you can see the occurrence of LED will become faster. If I decrease the frequency, you can see the occurrence of LED will be a little slower. So that is the switching of FET, or in other words, you can say FET works as a switch. Same you can give it to the relay. This is for FET. And the third one, which is IGBT as a switch. For IGBT, Q plus 12 volt to T13, ground to T6. Here you have to give the square to T14 and output T17. Here also you can give the output of IGBT to the LED. See, if I decrease the frequency, the time period of LED on and off will be less. If I increase this, the switching period will be more. Same thing you can check on the relay, as you can observe over here. So this is all about this trainer board, which will give the semiconductors such as MOSFET, FET, IGBT work as a switch. For switching purpose, we have given LED and relay. Thank you for watching the video.